Hello everyone, welcome back. This is part 2 of section 3.6, logarithmic derivatives and derivatives of logarithmic functions and inverse trig functions. So we have seen in part 1 of the video the derivatives of logarithmic functions, and we saw some examples. Now we will see how to find out the inverse trigonometric functions and their derivatives. So first, derivative of sine inverse of x is 1 over square root of 1 minus x square. And you have the table, just as the way we did derivative of trigonometric functions. This table gives derivatives of inverse trig functions. You know that inverse function exists only when the function is 1-to-1, meaning it will satisfy the horizontal line test if you graph it. So you have to sometimes restrict the domain in order to make the graph pass the horizontal line test. So for example, if you take a parabola the way it is, then it will not satisfy the horizontal line test. But if you take one side of the branch, then it does pass the horizontal line test, which means that the horizontal line should cross the graph only once. So sometimes we have to restrict the domain in order to make the function 1-to-1. So we know that sine inverse x and all these inverse trigonometric functions with the restricted domain pass the horizontal line test. So derivative of sine inverse of x is 1 over square root of 1 minus x square. Derivative of cosine inverse of x is negative 1 over square root of 1 minus x square. And derivative of tan inverse of x is 1 over 1 plus x square. Derivative of cosecant inverse x is negative 1 over x times square root of x square minus 1. Derivative of secant inverse of x is negative 1 over x times square root of x square minus 1. Derivative of cotangent inverse of x is negative 1 over 1 plus x square. So let me show a couple of them here, and then you can try the rest of them. Prove that derivative of sine inverse of x is 1 over square root of 1 minus x squared. So the function here, this one is a given function. We will call it f of x or y. Okay, f of x is sine inverse of x, and you're finding the derivative of that, inverse sine x. So let's assume that let's call y equal to inverse sine of x. What does that mean? If you move the sine to the other side, or if you operate both sides by sine, if you take the sine of both sides, then sine y, this side would be sine of sine inverse of x. So it is x by, we know that f composite f inverse of x equal to x itself. So if you take sine of sine inverse of x on the right hand side, it will become x. Now let's take the derivative on both sides. Now we can apply implicit differentiation at this point. So d by dx of the left hand side is d by dx of the right hand side. What is on the left hand side? Sine of y. What is on the right hand side? X. What is derivative of sine y though? Now you are going to apply the chain rule, outer derivative times inner derivative. Outer derivative is cosine of y, then inner derivative is derivative of y, which is y prime or dy by dx. Derivative of x on the right hand side is just 1. Now if you divide both sides by cosine y, you get dy by dx equal to 1 over cosine y. But what is cosine y in terms of x? So we know sine y equal to x. So see, if you look at this step over here, it is sine y equal to x. What is sine y in trigonometry? Sine of something, sine theta is opposite over hypotenuse. So if I take y to be this angle, then I can consider x as x over 1. So it is opposite over hypotenuse. So then if you apply the Pythagorean theorem, then it will be hypotenuse square minus 1 leg square. So if I consider this to be 1 over cosine y, 1 over, what is cosine theta? Adjacent over hypotenuse. right? So what is the adjacent side in this right triangle? 1 over 1 minus square root of 1 minus x square. Hypotenuse is 1. So if I apply, if I do cosine of y here, that is square root of 1 minus x square. So it will be square root of 1 minus x square in this denominator. So what is y prime, or what is derivative of sine inverse of x? Sine inverse of x, that will be nothing but 1 over square root of 1 minus x square. All right. That's how you derive the formulas on the table. So we did this one. We can try this one also. Prove that derivative of tan inverse of x equal to 1 over 1 plus x square. So as we did earlier, we will call this function the function that we are finding the derivative of as y. So let's start with that step. So let y be equal to tan inverse of x. So if you operate both sides by tan, you'll get tan of y is tan of tan inverse of x. With the same argument, it becomes x. So it is tan y equal to x. Now let's do the derivative on both sides. So do derivative of the left-hand side equal to derivative of the right-hand side. So derivative of tan y, derivative of x. What is derivative of tan y? By chain rule again. Outer derivative, which is secant square y, times inner derivative, we'll call it y prime or dy by dx. Right-hand side is derivative of x, which is 1. So if we divide both sides by secant square y, so y prime is 1 over secant square y, which is cosine square y, or cosine y the whole square, correct? So y prime is cosine square y. Now let's construct the triangle the way we did last time. So, and let's take this information, tan y equal to x. So we write x as x over 1. What is tan theta equal to? Tan theta is opposite over adjacent. So tan y equal to x over 1. So if you construct the triangle with the y as one of the angles, then the opposite side to y would be x, adjacent will be equal to 1. What does it mean? So in a right triangle, then the hypotenuse will be a square of leg 1, square of leg 2. So it's 1 square plus x square. So 1 plus x square. So, but what is cosine y in the triangle? Cosine y is adjacent over hypotenuse. What is the adjacent? 1. What is the hypotenuse? 1 plus x squared. So cosine square y is this is square root here. So it is square root here, but we are taking cosine square y. So we have to take the square of this. Which will be 1 over 1 plus x squared. So y prime, or the derivative of tan inverse of x inverse tan x equal to 1 over 1 plus x squared. Okay. Let's say derivatives of logarithmic functions. There are some additional suggested problems from the exercise. These are additional suggested problems. All right, there are some problems here which are marked star, which are homework questions. Some of them will say practice test, practice final, and some of them are just you have to learn them for the methods. So if you would notice here, we will do a couple of problems from here. One for some of them for logarithmic, some of them for inverse. So you might see some of these problems which are already done in the chapter videos. Please check them out, or in the practice exam videos I've already done. We will try something different from those problems that I have already done. So let's take, for example, this number 12. So number 12, we are asked to find out the derivative. So find the derivative of what it means is we have to find out P prime of T. That's what being asked. So we have to find out derivative with respect to T. P is a function of T. So here, before we actually get to the derivative, we can actually take this as ln of something, and then you can do derivative as 1 over that something times derivative of something. That is one way to do. What you can also do, we can use a property of ln. So this can be written as t squared plus 1 to the power half. So we mentioned the three properties that we will be using quite often. In the beginning, I stated that these are the properties that we will be using. So we are going to be using the third property known as power rule of ln in this problem. So I'm going to write that as a power, so which means ln of t squared plus 1 to the power 1 half. Then you can move this 1 half in front of ln. So you can write that as 1 half of ln of t squared plus 1. That is pt. Don't do the derivative yet. Now you are just doing the algebra part. Now in this step, you take the derivative and write. Take the derivative on both sides. So it is p prime t on the left-hand side. So it is derivative of the right-hand side. It is 1 half. So ln of t squared plus 1. So it is 1 over t squared plus 1 chain rule. And then derivative of t squared plus 1. So ln of something, whenever you do ln of something and you do the derivative, what does that mean? It is 1 over that box, whatever is the argument of ln, times derivative of that box. This is by chain rule. Outer derivative times inner derivative. So that's exactly what we have done. Derivative of t squared plus 1. So 1 over 2 times t squared plus 1. The derivative of t squared plus 1 is derivative of t squared is 2t. Derivative of 1 is 0. So which is t over t squared plus 1. So p prime t is t over t squared plus 1. As I said, whichever says practice test or practice final, those problems would have been done in the practice exam videos. So let's try this one, which is a new problem in this handout. So which is also a practice exam question, number 51. Y equal to x to the power sin x. Y equal to x to the power sin x. That is 51. So here you notice that the base is a function. The exponent is sin x. That is also a function. So it is of the form f of x to the power g of x. So we know that when the expression is of the form f of x to the power g of x, you know that you have to apply logarithmic differentiation. So if you look at this point number 4, that's what it says. You have to use logarithmic differentiation for this. So let's try that. So first step is to take ln on both sides. Step 1, to take ln on both sides. So you get ln of the left-hand side equal to ln of the right hand side. So what do you see on the left hand side? Y. What do you see on the right hand side? X to the power sine x. So ln of y equal to, now you use the power rule of ln. So sine x comes in front, sine x times ln x. Okay, now you take, in the next step, you take the derivative. So take the derivative. Which is d by dx of ln y equal to d by dx of sine x times ln x. So it is ln y here. So it is d by dx is what we do on both sides. So it is derivative of x, but this is ln y. So y is a function of x. So we have to use the chain rule, outer derivative times inner derivative. That's 1 over y times y prime equal to, now you notice that this is product of two functions, right? So you treat one of them as u, the other one as v. So u equal to sine x and v equal to ln x. U prime is cosine x, v prime is 1 over x. So d by dx of uv, product rule here of derivative, product rule for derivative. So it is u v prime sine x times 1 over x, u v prime plus v u prime. All right. So we get 1 over y times y prime equal to 1 over x sine x plus cosine x times ln x. So what is y prime equal to? Or multiply both sides by y. Multiply both sides by y. You get this y and y cancel out. So you get y prime equal to y, which is x to the power sine x times 1 over x sine x plus cosine x ln of x. So let's try some problems involving inverse functions, inverse trig functions. Let's try number 63. So derivative of, find the derivative of the function f of x equal to sine inverse of 5x. So 63, find the derivative of inverse sine of 5x. F of x equal to sine inverse of 5x. So if y equal to, we know the derivative of inverse sine of x is 1 over square root of 1 minus x square from the table. So if you look at the table, so the first one is 1 over square root of 1 minus x square. We even proved it. So here what you have to do, so if it is the argument of sine inverse is x, what you have here is the square of that one, right? So in other words, if I write this differently, sine inverse of a box, if I imagine that to be something, not necessarily x, it means 1 over square root of 1 minus box square times derivative of the box. So if you take derivative of x, which will be 1, okay? Because it is 1 in this case, we don't write that. But if it is something else in the box, then we have to find out the derivative of that. This is coming from chain rule, outer derivative times inner derivative. So when you do, if I call this one as y, which is sine inverse 5x, then dy by dx would be 1 over square root of 1 minus, what do I have in the box? Now 5x. So 5x inside the box, that is squared. Then I have to do one more step, the derivative of 5x. So it is 1 over square root of 1 minus 25x square. Derivative of 5x, the whole square is 25x square. Derivative of 5x, that will be 5. So I can write dy by dx as 5 on top divided by square root of 1 minus 25x square. Let's try one more of the inverse kind, maybe the last one. Number 68. Arc cosine of square root of x. So f of x equal to arc cosine square root of x. Arc cosine, another way of writing it is cosine inverse. So this is given as gx in the problem. So it can be written as inverse cosine of square root of x. So as we do the derivative of cosine inverse of x from the table, if you look at the table, it is negative 1 over square root of 1 minus x squared, the second one. So if you have cosine inverse of something, so if it is something here, it is negative 1 over square root of 1 minus square of that something. Then what else you want to know? And then derivative of that something. Derivative of that something. In this case, it is 1. So that's why we don't have anything written besides that negative 1 over square root of 1 minus x squared here. But what we have here is, suppose I have to do g prime x. So one more time, if I write like this, cosine inverse of something here, then I need to write negative 1 over square root of 1 minus some box square times derivative of the box, correct? So g prime x is 1 over square root of negative 1 over square root of 1 minus, what is going inside the box now? Square root of x. So I have to square the square root of x. So that is the first part, which is the outer derivative. Then I have to do the derivative of the box. Derivative of the box. That is negative 1 over square root of 1 minus x. Derivative of square root of x is 1 over 2 square root of x. So if I reorganize it, then it will be rearranged. It will be 1 over 2 square root of x times square root of 1 minus x. With the negative sign in front. That is g prime x. So that finishes this section. This is part 2. In part 2, we actually discuss some problems from the additional suggested problems and also inverse derivatives of inverse trigonometric functions in general. And there are some additional suggested problems given in this exercise at the end of the handout. Please try them as much as you can. And some of them are homework, some of them are in the practice exam or practice final. And then you can also refer to my chapter videos where I have done problems from this exercise. Hope this video helps.